As always, the first step is to count the valence electrons. So when we're counting up the valence electrons, we account for the fact that this has a -2 charge, so we need to add 2 electrons to the total. This results in 24 valence electrons, or 12 E pairs. Okay, so let's connect the outside atoms to the center atoms. That uses 3 of our 12 electron pairs. Now we complete the octet of the outside atoms. So each of these oxygens is going to require 3 lone pairs. So now each oxygen has 8 valence electrons. However, we used up all of our 12 electron pairs, and yet the carbon is electron deficient by 1 pair, so we need a double bond. So we'll use one of the sets of the lone pairs to convert that to a bonding pair, and that will allow carbon to gain 1 additional electron pair towards its octet. Let's rewrite the entire structure. Now I've actually gone ahead and drawn the skeletal structure of the resulting 3 resonance structures, because we'll see 1 resonance structure with a lone pair with the double bond on the left carbon, 1 on the bottom carbon, and 1 on the right carbon. Now to finish the structures, we simply need to fill in the remaining lone pairs. Now when we look at each of the oxygen atoms, we see each oxygen atom has a complete octet in all of these resonance structures, because each oxygen atom has either 3 lone pairs and a bonding pair, or it has 2 lone pairs and a double bond. All of the carbon atoms have 2 single bonds and 1 double bond. 2 single bonds, 1 double bond. 2 single bonds, 1 double bond.